coefficients thing. Like you guys have done that already. This is like the new thing. This like when it's adding on the numerator, not denominator, we'll do some of that, is essentially what you do is if you're dividing by this whole thing by 3x, you can separate the like the addition. So you would separate it like how it is on the numerator, and this is legal. Like you can divide each of them by 3x, like separate. So that's why you get this here. So you take the first term, divide by 3x, plus the second term, divide by 3x, and then you get your answer. And the same thing with subtraction. You just do them both separate. So all this other stuff is like old news that we've done already. So I think it's just easier to see an example. So like when you're doing just straight up monomial, I know we did some of this before, but like a lot of you do 24 divided by 8 and you'd like be like, yeah, 3, duh, you know what I mean? But the reason it's 3 is you can break up 24 into 8 times 3. And you know how we were doing like the dividing all the time? It's because when you get 8 divided by 8, you get 1 and you're left with a 3. Okay, so like when you're doing that with the monomials with all these like cycle variables everywhere, that's why it works. So with multiplication, it works. Okay, so with these, remember, like first, like attack like the numbers, 33 and 3. This one we have an x and an x. This one we have 2 y's and 1 y. And this last one a z and a z. So then if you break it up like that, then it's just looking at like what's left over. So like the numbers you'll treat like, I don't know how you want to say, like normal in a way. Like you're just going to reduce the numbers. So like 3 goes into both. So I do like 3 goes into 3 once, 3 goes into 33 11 times. And then this is like the most satisfying part because you can just go x divided by x, y divided by y, z divided by z. And then now you're just looking at like what's left. So like on the numerator, it's 11 and a y, right? Because that's all that stuff on the top. But then on the denominator, like I guess technically you could do this. Like on the denominator, it's just like a bunch of slashes, slash, 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 1, These are all ones. So you could do this, but that usually looks kind of dumb. Like on the multiple choice, you wouldn't see that. You would just write 11y. So just so you know, when it's just like nothing left, you just write the numerator. Like you don't write anything else. Okay. So hopefully that's like a little bit of review. Maybe we'll do one more and then have you guys do that next one. But it's the same thing here. Just like don't mess up like what variables are there and what's not. So like for this one, the numbers don't divide as nice. Ugh. Classic. Always happens. Yes, clear. There we go. Okay, so for the numbers, you have like 8 and 14, and then you've got an A and an A. You've got a B, no B's on the denominator, a C and a C. And maybe you don't need to do this, but sometimes it's just like easier to like match them up, So like here there's 2 X's, this one has 1. And then this next one only has 2 Y's. So I kind of like break them up so it's like easier to see like which ones all go together. So like I'll do the numbers. So like 8 and 14, like you have to think like what goes into both of those? Like 2, right? So that'd be 4 and 7. So that's how you're going to change those. And then the satisfying part is when you're like dividing everything. So like A's will go, the C's will go, an X will go, and that's it. So then what you do is you're going to like whatever's left on the numerator you're going to write and whatever's left on the denominator you're going to write. So like the 4's on the numerator, the B, and a D, and an X, right? And then on the denominator, you've got a 7 and a y squared, I guess. Everything else got rid of, So then that's it. So that one is just so many variables. It's like hard to keep track of them all. But just think, like, kind of group them together. It helps. And like, you don't need to write it out like that, but it's always foolproof. Like, it's always going to work. So that's what I'd recommend doing. So why don't you guys do number 4, this one, and check with your people that you got it right. Yep. Nice. Oh, no plus though. It'd just be times because everything's multiplying. But it's like the right variables, if that makes sense. Oh, you dropped an X. You crossed it out right. You just forgot them. You have too many Z's. Because there are 3. Oh, there's 3 up there. You only wrote 2 of them. Yeah, that's right. Oh, okay. This is, 4 over this. Gotcha. Yep. Yeah, nice. Yours is close. You just have to divide these. Oh. But you did like the variables, right? Yeah, that's right. Yep. Yeah. Oh, yep. Okay. All right. Nice. All right. So I wrote them all out so you can see it. But yeah, on the numerator is like all these 1s and just a 4. And then this one was just an X and 2 Z's. So you could put the 1 there. On the multiple choice, there usually isn't a 1. Okay. So just, All right. Next thing here is when you have the adding. So these are like cycle ones, because there's like 1,000 variables. But like, I'll show you like what it's like, where it's coming from. So like for an example with like real numbers, think about, let's do like 30 divided by 5, for example. Okay, like obviously you guys know what's 6, like that's not like the issue here. But another way you could write this is like 20 plus 10, right? All divided by 5. I mean, why would you do that? But I'm just trying to like get you to think with like the variable ones, What's legal to do is you can do 20 divided by 5 plus 10 divided by 5. So like if you did 20 divided by 5, you get 4. 10 divided by 5 is 2. And there you go, you get 6. So I'm trying to illustrate like why it's legal to do this. So like basically what you did is you divided each one by 5 and separated the addition. So this is legal. Like this is fine. Okay, to do that. Now, if you did say the reverse, so if I got to get my death blood pen. Okay, so this is death. If you did it reverse, so like 5 over 30, right? Wouldn't that be 1/6, right? I just like switched them basically. So 30 divided by 6 over 1. So 5 over 30 is 1/6 because you reduce it. This is illegal. Like 5 over 20 plus 10. This is like really, really bad. You can't like break it up like this. This is like bad. So when it's adding on the denominator, it's really bad. And if you still don't believe me, like we can keep reducing it. This is 1/4 plus 1/2. So this is 3/4, which obviously they're not the same, So like you cannot separate addition on the denominator. Okay. It's because of like the order of operation idea, but for both of them, but You cannot do it when it's on the denominator. The numerator checks out, okay? So you can do it on the numerator, not on the denominator. It's hard. It's like confusing on remembering which one is which. So basically the way you do these, like now the psycho kind of ones, is you're going to divide each of them separately by this. So you're basically going to have the a squared bc and plus abc, you know, like normal, but then you're going to do each of them divide by abc. So it's like two problems in a way. So now it looks like the other ones you were doing. So now it's like you're doing this twice. Okay, so you're going to simplify the first one and then simplify the second one. So like if you want, like you can go ahead and like write out like 2 A's, a B, and a C, and then cross off stuff. You know what I mean? Like, and then, well, I guess this one's kind of goofy to rewrite, but that's okay. You can kind of see it like the other one's like everything's gone, you know? So this is left with a measly A, and this is like slash, 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 aka 1, 1, 1. So this would be A plus 1. It would reduce to. Okay. So it's basically the adding ones, you're doing like two problems in one, kind of, because you have to divide them each like separate and then like simplify it out. Okay. So then for this one, which like looks a lot more psychotic, is like you're going to have 18x cubed y squared z minus 24x squared y cubed z, and then you're going to divide them both by this beast. So you're going to divide both of them by negative 12x squared yz, which is so obnoxious, but it's fine. Z, and you're going to do them each separately. So again, I just broke up the subtraction, and then now you're going to do it like you did those other ones. So like you're going to do like the numbers and the x's and like cross them off as you go. So like the numbers, right? So you'd like simplify those, and then you'd be like, okay, I've got 3 x's up here, 2 down there, 2 up here, 2 down there. Then you're going to do 2 y's here, 1 there, 3 here, 1 there, and then z, 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 and then you like slash them, you know? So the subtraction ones and adding ones, it's like extra in a way. So the numbers, you're going to like simplify. So like what, 6 goes into 18 and 12, you think? So 6 goes into 18 3 times. 6 goes into negative 12 negative 2 times. Or just like write it off to the side so I don't mess it up. And then this part I love because it's like choo, choo. And then choo, choo. Okay, so then whatever's left, you're going to keep on the numerator. So I've got, what, xy, I think? 3x and y. And then on the denominator, I just have the negative 2, I think. Okay. And then you do the same thing with the other one. So 24 and 12. Well, negative 12, I guess. Well, negative 12, right? Or 12 goes into both of them. So this changes, so be careful, this changes to a negative 1, right? And this one changes to a 2, right? Because 24 divided by 12. Or you could just put negative 2. I don't know. It's whatever you want. And then x, y, z. So we're left with 2 y squared, it looks like. Right? Yeah. And then this one, just a negative 1. Now, I purposely wrote it like this because these negative signs are going to drive you nuts. If it's multiple choice, usually how they'll write this is negative 3 halves xy. I don't know why they really like it like that, but they usually write the number as a fraction if there's no variables in the denominator. So it might is written like that. And then the other thing is, do you see how this is negative and that's negative? So a negative times a negative gives you a positive. So that can get kind of confusing. And then what's left, because you don't want to divide by 1 because that looks kind of dumb, you would write it like this, 2y squared. So like because it's dividing by 1, I didn't write that part. But the negative and the negative cancel out, so it turns into a positive. So the other way you might see this, again, it's kind of like you're at mercy of multiple choice. You're like not sure what it's going to be. Like all of these are the same. Like maybe it'll look like this. It's just like what they like to have the fraction look like and what they like to have the negative. These are all the same. Like this one, all of these are the same. You just have to know like which one it is. Wouldn't it be nice if they agreed? I think so. Okay. All right. Then here's all the deaths. The death zone. These are all dumb things people do. No offense, but like it really is annoying. Okay, so this is what people do. They go, woo, 1/3. Do you see what I'm saying? They like just cross it off because they're like the same. Choo choo. If this was multiplication, yes. It's addition, so no. Because like obviously it's 2/5, right? Like it's supposed to be 2/5. You can't just start slashing stuff. So this is not this is bad. Okay, don't do that. Okay, so then when we get here, same thing. People go, woo! And they say it's 1/3. Bad. Okay, this is actually the correct answer is this. You can't simplify it at all. This is done. You can't do anything to it. So the adding on the denominator, if it was multiplying, it's a different story. Adding is where it's like, can get confusing on what is what. Same thing here. Do you guys know what people write for the answer for this one? That's wrong. Do you have a guess? Someone said it. Yeah, 1/4. They go whoop, and then they say 1/4. Okay, that's wrong. Same thing. This is correct. What's correct is how it was before. So don't go like slash and happy. Do you know what I mean? It's good in multiplication, but not in addition. Okay, so just be really, 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 really careful. Okay. Okay, can't put that up there. All right, so